example. And what you can do, is, and I have it indicated here on my hub BRs, and the only reason I have it there is most networks aren't going to have an end-to-end QoS model. They might have, auto QoS or something like that, but for IWAN, you really have to make sure you're matching on that appropriately. N-bar makes your life easier. You can use layer 3 ACLs if you need to, but that's kind of how where QoS comes in. And so that's kind of the gist of what we can do with IWAN and what what it does behind the behind the curtain. But you might be saying, all right, DMVPN, IPsec, QoS, front door reverse, PFR. It's a lot of pieces of the pie to try and manage, and especially from a command line perspective, you might say that's too much to manage. And if you feel that way, but like most people do, they hear SD-WAN, they want that single pane. So what IWAN has is actually a collection of tools, and I'm just going to kind of write them out here, and we'll talk about them independently. So we have live action, we have prime, we have APIC EM, we have glue. So live action, most people who deploy IWAN, and even Cisco themselves, would say that if you have an IWAN deployment with anything more than like 10 spokes, you should go with live action. And the reason for that is while you can log into these routers and do some PFR show commands to figure out what's going on, it's really hard to get visibility from a large scale what exactly is your network doing. And so you can use live action and say, I know that I have a phone in my data center, and I know I can talk to my remote site, but what path is it taking? Live action is really good. It will give you a visual path and say, I see it going through the internet, and I see it landing on my phone. But say there's a spanning tree blocked port in there, or say there, for whatever reason, on one of our layer 3 devices, that we are modifying the DSCP marking to something so that it's not treated correctly when it lands on our hub BR. Live action will allow you to visualize that and also make the change to fix it. So I can right click and say resolve. It's almost that simple to be able to fix these issues. Prime is Cisco's tool essentially for facilitating the rolling out of this network. You have 1,000 of these sites. The last thing you want to have to do is build tunnel configurations for every one of these sites, because it's just going to become a management nightmare. Did I deploy the right AAA config? My SNMP, did I put the right community value? Prime allows you to build a template, and you can have fill in the blank values, so that as you deploy this to all of your remote sites, 99% of your configs are identical, with the exception being things like, my tunnel IP address, stuff like that. APIC EM is Cisco's attempt at that single pane. It's very early stages right now, but one of the nice things about it is because it's a single controller for all of your remote sites. In its current state, if I wanted to change, add a mission critical application, I'd have to go to my remote sites either manually or using Prime or something like SolarWinds ANCM to push that config. I can use APIC EM, click on Exchange as an example, and say, I want that to be mission critical. I want that to fall under the policy that has MPLS preferred. I drag that application on the mission critical, it pushes that config to all of my remote sites, and seamlessly, all those changes will take the path that falls under the policy that's configured on your master controller. So, that's its benefit, is instead of having to use these other tools to manage what happens on the IWAN setup, you can use APIC EM to do that. I would say the only thing to consider is it's on the roadmap, rumored that APIC EM will be integrated with live action down the road. And just to speak to what this means, it just looks like a weird word: application policy infrastructure controller enterprise module. So you might be familiar with APIC within an ACI fabric. This is the enterprise module version of that. The same thought process, and I have a centralized controller within my data center. There's a centralized controller on my enterprise. And lastly, I haven't had much experience with this, but Glue is kind of an automation and orchestration tool. Kind of allows some programmability. I can't really speak to why you would go with Glue versus APIC EM, but it's something worth looking at. So that is my engineering level of why IWAN and what IWAN is. So lastly, let me go ahead and just kind of erase this, and we'll kind of look at this from a much higher level. You know, if you're trying to convince this to your manager, your executives, you might say, what is IWAN and why are you pitching this to me? Some of the things that you, as a network engineer, you may not care about because one, you just don't care, and two, because it's outside of your scope of responsibility. So why IWAN? The biggest piece that sells itself is operational cost. Operational cost savings. Think about it. Like I said before, you have a location that the only MPLS connection that can provide is T1. You kind of are painting yourself in a corner where as users grow, you can't grow with it. If with IWAN, you can go to a commercial internet connection that 9 times out of 10, your costs are going to be lower than that T1 connection. Like I said, you may lose your SLA, but at this point we don't care. We have redundant paths, so we don't need to make sure that single path falls into the latency and loss parameters that we've defined. CapEx, your capital expenditures. You have 2811s on these remote sites. They're falling out of support. You need to upgrade these. IWAN sells itself in that, hey, you're already doing a hardware refresh. Why not, while you're doing your hardware refresh, lower your operational cost? So that's a big point right there. Like we said earlier, and engineers care about this, but so will executives. Transport agnostic. What does that mean? Transport agnostic. That basically means that we don't care. What's under the hood, what our underlay is irrelevant to us. We build an overlay over, we can build an overlay over AT&T, mom and pop ISP, anybody. So if we have any issues with, hey, we're having a lot of loss with AT&T and their support's been really crappy, let's just abandon AT&T and go with level 3. And that gives us the flexibility that otherwise would just be a pain. If you're peering with level 3, you know, to have a new MPLS connection brought in is much more difficult than just ordering a commercial internet connection. So when you're talking about this type of setup, you're saying, wait, my operational costs are lower, my CapEx is pretty much null and void if you're doing a hardware refresh. I'm transport agnostic, and I'm also getting increased redundancy. / quick failover. Maybe at an executive level, they don't know redundancy and quick failover, but they'll know that application availability is increased. If I have these multiple paths, essentially what I'm getting is, I have the potential to have, primary, secondary, tertiary, and fallback. That means my failover is going to be potentially sub-second, and I don't have to worry about that application being unavailable because the MPLS provider presence was in the same colo, and for whatever reason that failure caused them both to be unavailable. So, from an IWAN perspective, it kind of sells itself on just your cost savings and for the features that it provides. So I hope I kind of represented myself a little bit better this time. So, okay, I'm recording still. So if you have any questions, please reach out to me. I appreciate it. Thanks for taking a look.